Hello everyone, thank you for being the audience for my presentation. So today I want to talk about skin condition classification by using automatic image machine learning technique. So the outline for this presentation including first we talk about motivation, why we want to do this project. Then we talk about background, so general skin types and conditions. Then we talk about data collection and pre-processing before we do any feature extraction. Next will be features we extracted from the image, including RGB, HSV, different features. Then features will be sent into classifiers for recognition. Next, we talk about and discuss experimental results we obtained for the data we collect. Finally, we have conclusion and also the future work we plan to do. Okay, so first of all, introduction for this project. Why we want to do skin type classification. So as we know, skin is the largest organ for human being. It accounts about 15% of body weight, and the skin care product occupy a gigantic portion of consumer market. According to research, in 2021, the skincare product market globally is about $130 billion, so it's huge. Second, the skincare and related product increasing every year, about 4.2% from 2022 to 2030. So you can imagine, right? This huge market is also increasing. So therefore, right, it's important to know, right, which skincare product you should choose and how to help people select the right skincare product, right, for their skin type. So choose a good, right, or suitable skincare product and follow the suitable routine is essential step for everyone for keeping their skin healthy. So first of all, before choose any product, you want to identify your skin type and status. This is the most crucial step, right, before you do any purchase. So how can we determine, right, the skin type or skin condition? There are some examples. So currently, right, if you want to identify your own skin type or anyone else's skin type, typically people use skin type test or skin test quiz, so as like a questionnaire, and bare face method. So use a very special sort of paper, right, and try to use a blood sheet method and find out your skin type. However, right, all those methods highly depend on tester's subjective personal experience, right, and judgment, so they are not very accurate. Recently, there are also many researchers they have explored using image processing method, right, to diagnose skin diseases and disorders. However, right, they are most likely, focus on skin disease, right, and disorder. Not many available research for determining the general skin type, right, for ordinary people. So our motivation will be use AI technique, right, machine learning method to identify or recognize a general human being skin type in order to help them select the suitable skincare product and the suitable routine. So for general people, right, there are 5 types of skin available. For example, this is scaly skin, right, oily skin, where you can find reflection because of the oil. Skin with red spot, dry skin, and normal skin, right? Very interesting. Only 5% of human beings considered have normal skin, not too oily, right, not too dry, and in some cases, right, you can find combined, right, combination or mixture of skin type in one person. For example, in T shape, it's kind of oily, and in cheeks, right, kind of dry. And sometimes, skin with red spots can also be, confused and mixed with skin with acne. And for oily skin type, you may also find, acne. So it's kind of complicated problem, right, for identify one single person's skin types. Maybe just one, or maybe a mixture of different types. So now we talk about data pre-processing and data collection. So we collect data, from internet, and we selected different types of data, skin type, right? Try to get a balanced data set samples. And for the data we collected, we split data into training set about 80% and test sample set about 20%. So the image we collect, right, will be an entire face. So it will be cropped or bitten features that are related to the condition that compromise the classes. For example, for an image of face, right, we may get cropped one area, just it's oily, right, or dry. Then we do some pre-processing, including converting each image to grayscale, compression, red, green, blue dimension of the input tensor, right, to just one layer of 2 dimension, representing image width and height. Additionally, the image will be also resized to 100 by 100 pixels in width and height. So here are examples, right? We crop and resize the data sample what we have. So this is original image, kind of cut, right? Crop from original face image. So you can find only the related, areas selected for model training and test. Let me resize image to 100 by 100 square shape. So we have different image, right, from different skin type. Now we talk about features we can extract from the pre-processed image. So according to type of skin, right, each type contains its own color distribution. For example, oily skin, there are more reflection, right? So, and red spot or acne skin have more red pixels than any others. So we need to convert RGB into grayscale and find the distribution of oily skin, normal skin, dry skin, scaly, and red spotted skin. So here are examples of 5 different skin type, right? The distribution of the color converted to grayscale. We can find different type of skin. They have different, right, distribution in color. Another feature we tried is called HSV, hue, saturation, and value data. So we need to convert RGB data from the original image into HSV. And here are the examples, right, for different skin type. We have scaly, red, dry, normal, and oily skin. The equation we use to convert from RGB data into HSV data, you can find from our published paper. Now classifiers we use in this project. We tried care nearest neighborhood, right, KNN, like this one. So find the nearest neighbor, right? Will determine the class. We also have naive-Bayes classifier. So this is a naive Bayes classifier, and we also use a neural network with some hidden layers. So there are three very popular classifiers. So we also try to apply these classifiers for our problem, see which one give us reasonable outcome performance. So for KN, the histograph of color classifier data feature was used, and we get accuracy about 50%. So this is not very attractive, right? However, KNN generally used as a baseline, right, for assess other classifiers' performance. So we also, still keep this result. This one will be baseline, right, for other classifiers. And for naive Bayes classifier, we use RGB feature. Accuracy is about 76%, and F1 score is 87. So it's pretty, encouraged, right, for us to use this method, right, to classify skin types. For a neural network classifier, we use color classification, HSV histogram, right, and accuracy is about 60%. So this one is better than KNN, but a naive Bayes, currently a naive Bayes classifier give us the best performance. Okay, so conclusion, this paper presents some preliminary results for using AI and machine learning to determine the general skin type. RGB HSV features have been extracted from the data set we collect directly from internet, and then we use KNN, naive Bayes, and the neural network as classifiers. The experiment based on our current results show that naive Bayes classifier performs the best based on our current data set. Future work, we want to expanding the data set, getting more data and improve performance. And we would like to try using feature engineering, select more suitable feature for this task. And we also want to do algorithms optimization, tweak different parameters and try other classifiers. Then we want to use users' feedback and validation, to improve the performance of system even more. Okay, so here are some reference for this book, for this research